So for the next session, we would like to welcome Craig Risi. Craig is a QA architect at Repel Group. He is also a frequent blogger and has published the book Quality by Design. So Craig would be conducting a lab session on the topic, a tester's guide on unit testing. To know more about him and to see his video interview, do check the link below. Sir, now I'll stop sharing and the stage is all yours.
Perfect. Thanks so much. Really appreciate it.
Thank you,
So thanks so much to everyone for joining this talk. I'm just going to share my screen now.
Yes, we can see your screen.
Fantastic. Can you see my slides?
Yes, sir. Yes, sir. Everything is clear. It's visible.
Okay, just hold on. Okay, yeah, just making sure everything's okay. Sorry about that. Cool, but yeah, thanks so much. Wanted to talk today, obviously, about a topic that is important to me and hopefully to many of you, and it's about unit testing. And I think unit testing is not something that many people naturally gravitate towards. I think as testers, it's something that we tend to steer clear of, and kind of like it's something that the devs do. It's this dark art, and we kind of let them be, and we never really get involved. And similarly, a lot of developers maybe don't like actually unit testing. It's not something that they enjoy doing. They want to just get onto their code, and if you ask them to work on the unit testing, it's not something that they're willing to do for, quite easily. And so I think, it's an important topic though, because, there really is a lot of important testing that we can do at this layer. And I'll obviously unpack a little bit more of that during my presentation and workshop. But I do think that even though it's something that a lot of people are not too excited about, I am excited that you guys are on this call, because I do think, there's definitely a lot more that we can start doing within the unit testing space that I think a lot of people can learn from it. So hopefully you guys can start getting more involved. And I think particularly as testers, that you guys start getting involved. Again, it shouldn't be this dark art that only the developers are getting involved in, but something that more testers are actively wanting to get involved in. A little bit more about me. They did already share quite a bit about me. I'm a QA architect at a company called REPL, as part of Accenture, and I also design board games under Risky Games banner. But then I've also got the book Quality by Design. If you want to learn more about a lot of different sort of quality design practices that I work towards and that I try and instill in the projects that I'm part of, you can get this book and be able to, find out more from there. It's not specifically about unit testing per se. There is some stuff on unit testing there. A lot of what I'm going to be talking about today is perhaps a little bit more elaborate than what I talk about in my book, but a lot of the holistic approach to testing that I like to kind of follow in the projects that I work on is in that book. Should you be interested. And I'm from Cape Town, South Africa, so I thought I'd also just share a couple of pictures if you want to know a little bit about me and where I'm from. This is also just a little bit more about where I'm from. This is the city I live in, and as you can see, there's a wide diversity of different landscapes and nature, which is one of the reasons why I love, Cape Town, and I love South Africa, is we have a really good mix of nature that we get to be around. So yeah, really grateful to be a part of living in this country. But what I really wanted to start talking about first, before I delve into unit testing specifically, was really the concept of breaking down the puzzle. And I kind of view software development as kind of like building a puzzle. There's multiple different parts and components, as I'm sure each of you have experience, and there's lots of different parts to software development. And it's really that we're trying to build this big puzzle of different software components, different pieces of code, different software architectures, and trying to, and often different, applications all working together to try and build this holistic system that now we need to build and maintain. But let's say, for instance, I were to come to you and say, I want to give you this puzzle that I want you to build, and I want, and I want you to take this puzzle box, let's say it's 1,000 pieces, and now you need to test that this puzzle can be built, and that once all 1,000 pieces are together, that it matches the image that's on the box. How are you going to do that? The most obvious way of doing that is to take the puzzle and literally take all 1,000 pieces and try and build the puzzle. And that's a lot of fun. It's great to do, and it's definitely the most foolproof way of knowing for sure that every single piece is in the box, and that it all builds together and comes together and makes this picture that's on the box. But it's incredibly time consuming to do that. If you were to try and build this puzzle, and put all 1,000 pieces together, it's going to take you a really long time. And even if you're a really fast puzzle builder, it's still something that doesn't necessarily, it's not quick and easy to do. And then what if I told you, okay, great, well, you've done that. Well, here's another 1,000 of the exact same puzzle, but I need you to test that every single piece that should be in this box is in this box. That just doesn't scale well. Now you're going from, even if you start building the second, third, fourth, fifth time, by the time you've built 100 of the exact same puzzle, yes, you can do it very quickly, but it's still really time consuming. No matter how good you get it, it's still going to take a long time, and it just doesn't scale well. And yet in the software development world, where we're getting to now is we're really asking teams to be able to deploy software as fast as possible. We're asking teams to be able to deploy software as frequently as possible, and often multiple times a day, to be able to push code into production and ensure that everything works together. We don't have time to be building puzzles. If we're going to try build puzzles and then test that they're working all the time, it's just not feasible. There's no way we can test a complex software system that way, quickly, efficiently, and fast. And so what we need to start doing is having that mindset of breaking down the puzzle. Instead, a way that I could test a puzzle box, if you were to give me and tell me, okay, well, here's a 1,000-piece puzzle, make sure that all the pieces are there. I know that there's 1,000 pieces in it. I know that each piece has to match certain specifications. And so I don't necessarily, if I know that information and I can identify what each individual piece should look like, I no longer need to build this puzzle. I need to just make sure that each piece is there, and I can go scan this piece, scan this piece, scan this piece, scan this piece. And while it's still time consuming, it might take a little bit longer to be able to map out and get an idea of how each piece were to look like. It's now a model, though, that if I were to do this 1,000 times, it scales quite quickly, because I spend a lot of time the first time doing it, and it's still a little bit more time consuming to be able to scan each individual piece, but it's a lot quicker to scan 1,000 pieces and check that all 1,000 pieces that should be there are there than to try and build this puzzle. And I think it's the same sort of approach that we should have to software development in general. I think too often we think about software development as trying to build this whole big piece of puzzle, and rather trying to break it down into smaller pieces. And specifically testing. As testers, I think we can often, focus too much on the whole sort of end-to-end picture of an application, how it works, and most testers I speak to default to that mode. Whereas what we should really do is try and find out, how do we break down this puzzle, and how do we rather focus on smaller aspects of it? Or, as I like to describe it, how do we test smaller? So instead of testing a whole end-to-end application all the time, and every single time we're running this whole end-to-end regression, why don't we just focus on, instead of making sure that end-to-end everything works well, that we just focus making sure that every single component that makes up this end-to-end application is exactly as expected. And that's the concept behind testing smaller, that we're taking one big application and we start to break it down into small testable components that can then be more easily scaled. Yes, you might feel a little bit of discomfort as a tester, because you like to have that hands-on focus, you like to be end-to-end, you like to understand an application and how it all fits together from one side to the other. But again, it's not something that is really feasible in the long run. If you're trying to scale this and do it every single day, day in, day out, you would rather want to be able to understand how each individual component fits together. And it's a lot easier to test that than it is to be able to, again, test an entire end-to-end suite all the time. But to give you an example of how that might look in a software application, I'll show you this is a high level how a lot of modern software applications look like. They will have multiple different services. Those services might be microservices, they might be a little bit bigger, they might be entire applications depending on the type of system that you're working with, but you'll have multiple different services that then need to speak to each other. And then you'll typically have them talking to each other either via an API or some sort of other messaging system that now got to talk to each other to be able to get things done. And then you also will have a database system. And these days, most software systems will have more than one database system that needs to be able to keep track of data depending on what it is that you're doing. And if we're going to now try to take that testing, and this is, again, you might not be doing this, but this is typically how I found a lot of testers tend to throw themselves into projects, is they now go and when they want to now test everything and understand how these things work, they will now go and do end-to-end testing of how all these systems speaking to each other, making sure that the data is safe across everything, that the data is going correctly between all the different systems, and make sure that every single message between all the services is getting tested correctly. And there's nothing wrong with it. It's a really good quality-oriented approach to take, because if you can take this holistic view and test an application, make sure that everything works thoroughly and try and focus on a lot of your testing effort and get in there, you're going to end up with a really good, high-quality system. But it doesn't scale well. Again, it's that whole thing of building a puzzle. It's the best way of doing it, but it doesn't scale well. You can't go do this in a repeatable manner every single week, every single sprint, to be able to go into production multiple times a day and try and do this type of testing. It's just simply not feasible. Rather, how you want to consider your testing is to rather break things down into a smaller system. So we know that there's 5 or 6 or 7 different systems that we need to interact with, and then rather have that service. So we now know we've got this service, and this service needs to have some sort of database that needs to interact with. And we need to, rather than break down that service into a very small testable way with a testable service of how it needs to work. And I've put those 2 squares on the left and right as an, if I do this input with the service, I get this particular output. And then I have one data structure that I know it needs to integrate with, and I mock that out, and I mock out all the dependencies. I know that I can test this one service really well. I don't need to worry about how the service interacts with the other 5 services that make up our application. I need to just focus on just this one. I'm not worried about what goes on. I need to make sure that this one is well tested. But if I can do that, and then I do the same for system 2 and system 3, system 4, system 5, I get to something where it sounds like it's a lot of testing, it's a lot of work, and it is. But again, it scales very easily. Now all of a sudden I can test and deploy into system 1 multiple times, because it's a lot quicker and easier to test. I don't need to worry about what's going on in the other services. I can do the same for 2, 3, 4, and 5. That's not saying that there isn't a focus on end-to-end testing. It's not saying that we're not worried about how this whole thing works at an end-to-end level. What we're doing is focusing on the smaller component of the software system and how it's supposed to work. And in understanding that, we can design tests that are easier to test. We can design things that are easier to automate, and we can get through everything a lot quicker. And it's a lot faster to be able to write automated tests for that entire system 1 and make sure that it's working well, and for that system 2. And then we can do that across every single other system. It scales really easily. And if we want to introduce, if we were to go back and say, okay, but what about the system that we had? If we now had to go introduce a few more services here and have service 6, 7, 8, 9, it just makes the testing more complicated. Whereas if I do it this way, I just simply add another box and make sure that build my automation testing around it. So again, it's something that scales quite easily, and I don't need to worry too much about it. So if I can take that approach of trying to break down software systems into smaller parts, that helps. And that's obviously a key principle of really good software system design, is trying to break down bigger applications into smaller, more testable applications. But the same applies to the way that we now approach testing and testing software. We shouldn't be thinking about testing software holistically, but focusing on breaking down testing into as small components as possible. And that's where unit testing comes in. And I think why unit testing is so important. And I think most people are familiar with this testing triangle that I've got on the right-hand side here. I think it's in a lot of textbooks, it's in a lot of blogs. I've pretty much everyone I show this to understands the philosophy of it, that in order for any sort of testing foundation to work, you need to have a good base of unit tests, of which the majority of your tests should be unit tests, because they're they're operating at a code level, the developers are writing them, and then you go up to and have component tests, integration tests, end-to-end tests, exploratory tests. And again, every layer is important, but the idea is that the more solid a foundation that you have on the bottom layer, the easier it is to do the layer above it, and the less tests you need, and the less tests you need, the less tests you need. Again, this is a triangle that I think is very well known within the software development and software testing spaces. The problem I find is that if I've typically worked with a lot of testers, and then I give them an application to test, they jump straight away into the end-to-end and integration layer. And again, maybe nothing wrong because they're coming at it from a user and business perspective and trying to work with the application, trying to figure things out. But the problem is that if this entire pyramid is designed on having a strong foundation at a unit level and a component level, shouldn't that be where the testers focus on? And that's why I think we need to change the way that we think around unit testing as testers, because this is definitely something that if it's the most, if it's the part of the application with the highest number of tests, that should be where you want your testing experts to focus on. I'm not saying they need to do this exclusively. I'm not saying that developers shouldn't write unit tests, but I'm definitely saying that testers should be very aware of what's going on at a unit test layer and should be very involved in the process, because it's the most important part of this pyramid. If it falls over and you've got bad unit test practices, it doesn't make a difference how good your unit test layer is. Your pyramid becomes unstable. So it's very important that you get this pyramid right, but then it really, if you really want to get it right, you need to make sure that the testers are focused on what's going on in a unit layer. So I'm going to talk through a couple of other sort of benefits that it gets to. I mean, obviously why unit testing hypothetically makes sense. If you've got the highest number of tests at a unit layer, testers should be involved in that. But I think another really key benefit is something, is collaboration. I often hear of these things where developers and testers don't always quite see eye to eye, and the developers coming from an application in this direction, the testers coming from this direction, and there's a lot of misalignment in their approach and what they're doing. Again, I don't think that's healthy. I don't think that's how it should be done. And essentially, really what we're trying to achieve here is better collaboration. And I think if you can have testers involved in unit tests, it allows them to better understand what it is that the developer is trying to build, and it allows them to get to the point where they're speaking at the same language as what a developer is speaking and what's expected, of the developer and what their code needs to do. And so you can allow the testers to get involved really early on in the design, that they're getting really involved early on in what needs to get done from a software application and how it's built, and get to a point where they're working better together. And I think if you get testers more involved with unit testing, you see a lot better collaboration between the testers and the developers, and getting better alignment to testing and what needs to get done. And so definitely something which I would recommend. It's obviously the foundation for test-driven development. Again, another big thing that the software industry is about is test-driven development. And I use those inverted commas or those quotations when I say that, because I've worked with so many companies and I've worked with a lot of developers who are all about having test-driven development, because again, it makes sense. If you can design your tests right, if you can put your tests in place and then write your code to pass the tests, you just have better quality code. But there's a big difference between saying test-driven development and doing test-driven development. And if you really want test-driven development to work well, it's got nothing to do with giving the testers more time to automate and getting them to write better integration tests and stuff. It really all comes in at a unit test level. If you want this to be a success, if you want to make a success in your space of how to get TDD to work, you've got to get involved at a unit layer, because that's really where all the nitty-gritty and the like difficult stuff comes in. And so I think it's really important that if you want to make test-driven development work, you've got to get your unit testing in place. And it's important for the testers to get involved there to drive that process. It's not something that a tester can drive. You can't drive test-driven development in your organization if you are not involved at a unit test layer, because that's actually where the dev's code is. That's actually where they're writing their code to, and their code needs to pass unit tests. That's how you get test-driven development working. And so very important. It's reducing duplication. And I say this because I work in a lot of organizations, or where I see the devs and the testers operating completely independently of each other. So that the dev will go and build the code and write their unit tests, and then the like testers will go look at it completely independently, write their own set of tests and automated tests, and try and test everything to make sure it's working fine, and that's all fine and well. The problem is that if this developer is testing their stuff and writing unit tests, inevitably a lot of the scenarios that they've covered are already there, and now all the test is doing is going to test the same thing that's already been tested, and there's no need for them to do that, and they end up doing double work. There's a lot of duplication because now the tester is doing a lot of extra work that's actually already in place in the unit testing, and they're not aware of it, and so they're writing these complicated UI tests that they probably don't need because it can already fit in a unit test layer. And I'm going to give an example for this. Let's take, for instance, a simple requirement, and I'm going to use something that I think everyone can understand so that it's very basic. A requirement is any number entered into the text box between 1 and 10 must provide a valid response. Right now, I'm not too worried about what that valid response is, but this is essentially what you're doing. So I'm going to say, here's a text box, enters the numbers between 1 to 10. It must just, it must give an affirmative message. Anything else doesn't. What does a tester do? A tester goes and says, okay, great. Now I'm going to go on the UI screen where this box exists, and I'm going to write some UI tests, and I'm going to go into this, and I'm going to do some boundary value analysis, on this text box. And so I'm going to enter the number 0 and see if it should come up with a negative. I'm going to then go enter the number 1, and I'm going to go into the number 10, and both of those need to pass. Now I want to be smart and go 11 and check that that's an error. And then I'm going to do other things like add an extra digit to make it 100, and then try a lot of weird things like spaces and alphanumeric stuff and see what happens. And again, it's all fine and well. We want to be able to test this thing, but now we're writing all of these things at like a UI layer where this box has got to take a certain amount of input and be able to get it done. But the problem is that all this box is doing is being displayed on the screen. The actual code that's often testing that is sitting somewhere else. It's not this box that's now going to do all this validation. It's a piece of code that does this validation. And we're writing UI layer tests to do detailed boundary value analysis when it's not really necessary. Now, say, for instance, I'm going to say, okay, well, great. Here's the code for this. I'm going to have this code, and again, very basic code. You really should write your code more complicated than this, but high level, I'm saying I'm going to create a variable integer that's going to convert whatever comes into my text box into an integer, and I'm going to then have a simple if statement that if it's between numbers 1 and number 10, and notice equal to there, I'm going to say print valid, else print invalid, and that's all this piece of code needs to do. Now all of a sudden I know, okay, well, I don't need to worry about alphanumerics and spaces because it's literally just the numbers 1 and 10. Anything else is invalid. I can throw spaces, error messages, I can throw security testing problems in there, put all those sort of SQL, strange SQL queries in there. That's not going to work. It will literally just say invalid. So straight away I can see I don't need to have so many tests. I don't need to worry too much around having this exhaustive testing, with like every single type of boundary value. And I need to just make sure that I have a valid response and an invalid response. Great, I can reduce the number of tests. Secondly, this is happening at a code layer. All my button does, all that box does is really just display something. When I put it in there and push enter, it's now calling a function that now does this. So if I can unit test this part of the application and actually unit test and say, okay, well, I'm not going to write a UI script for this. I'm going to simply just say, okay, I've got some code and I'm going to write a unit test, and I can pass it at that layer. I don't even need the UI test. All I need to do from a UI level is make sure that the box is rendered correctly. Because I know that whatever goes into that box, it's now going to get passed through to this. And I've tested that at a unit level. I don't need to now do extensive boundary value tests, at an automated level against my UI. It's just duplication. B, it's a waste of time because it's just a lot slower to run a UI test, whereas I can run through a multitude of different permutations of these unit tests in milliseconds. So again, we're wasting effort if we're not really focusing on what's going on at a unit layer and then just trying to duplicate that testing elsewhere. If you can get it done here, you can save yourself so much effort later on. We all want to get defects early, and we all understand the concepts of catching defects early. And again, this is another sort of key thing, that if you want to talk about catching defects early, well, when's the best time to do it? Well, obviously before the requirements are written, great. But outside of that, as soon as the code is written, there's a failure in the code, you want to catch it. Now, if your developer's not doing a lot of unit tests, or if you've got no trust in what the unit tests are doing, and then maybe it's poor quality unit testing because you as a tester haven't really focused, you just wait for the dev to put it in a test environment and then you test everything again, you're going to get to a point where you're finding a lot of things. When they deploy into production or into like a test environment, you're going to test it and you're going to pick up, oh, well, this is not working, that's not working, that's not working. Sometimes it might be more complicated stuff, which is great, that's what you want to find. But sometimes you test something and basic things aren't working. And that's because there was no unit testing in place. And you shouldn't be finding that in a test environment where it's already been deployed to. That should be found the moment the developer pushes the commit button. It should be running a set of unit tests, say, well, hang on, this is actually not working. Your code is not working as expected. And we can find a lot of defects in the code a lot earlier on if we're actually focused on the unit tests that went into. Before we even started writing the code, we wrote the unit test. We had a good understanding what need to be unit tested. You will catch a lot of programming defects that way. And then you won't need to worry about what gets deployed into your test environments and worried about, again, doing extensive end-to-end testing, because your unit test will catch everything early. The moment the developer's written the code and committed it, they'll get feedback to say something's not working, and then they've got to go back and get it right. And so very important, you catch defects early this way. Another key benefit of writing unit tests and really good unit tests and getting testers involved in this, which I think is sometimes not always thought about enough, is that unit tests really are a good way of getting to understand the code. And I'm pretty sure many of us have worked on a project where there's a lot of documentation in place on how software is supposed to work, and then we're documenting the code and how the code's supposed to work. But inevitably, documenting code and code commenting doesn't, again, it's one of those things that doesn't maintain very well. The person might have started off with the best of intentions, but over the years, as the code's been maintained, the comments are no longer relevant, or people can't quite figure out what this used to do and why it used to do that, and so it becomes really difficult to be able to understand the code and be able to have it always documented and maintained, because you made quick fixes and you couldn't always keep the documentation up to date. But if you have good unit tests in place, code. If you want to understand what the code's supposed to do, don't read the code, just read the test. And if you've got really good detailed unit tests in place, that's the best way to be able to figure out how something is supposed to work, is by reading its tests and seeing, well, based on, if I've input in this value, it's supposed to do this, and you have a whole list of what this code's supposed to do across the different tests, then you'll be able to figure out what the code is supposed to do. So if you ever want to improve, code commenting and code documentation standards in a team, focus on getting the unit test right, because that will inevitably make it easier for future maintenance work to be done. And the same goes with traceability. Traceability is always one of those key things where it's important for testers to know that when a test fails, what requirements is it linked to? What we want to try to link our bugs to that test that failed, and then link it to requirements, so we can be able to better understand which requirement is failing more often and which test fails more often, and when we need to fix this defect, what tests need to be rerun. So traceability is a very important part of testing, but I sometimes think that we lose sight of the fact that we shouldn't just be worried about the requirements. What about the actual parts of the code? And through having unit tests in place, it improves your traceability by saying that this particular test failed, and this particular part of the test ran this piece of code. And so now we can break it down even more by saying, well, we've picked up a whole bunch of failures when we ran our unit test, and these are the pieces of code that cause the issue. And so now we know the actual modules of code that are causing the problems. And furthermore, if you run this on a regular basis and you look at which tests are failing most often, you can better get a sense of which modules of code are more problematic, and which ones probably need the most rework through this entire process. So something that's very important to do. And I think, again, if we don't do a good job at unit testing, we are losing sight of that important traceability aspect in our code, and you definitely want to be able to be on top of that. Another benefit that people might not think about when they think about unit testing, but it's improved ideation. The whole idea of test-driven development is not just about wanting to write your test before you write your code so you can catch it earlier. Yes, that's part of it. The other part of it is the more you start thinking about, well, what sort of test scenarios does my code need to pass? And you start to map that out. And especially if you as a tester can bring your testing brain into it with the developer and say, well, we need to think of all these different sort of permutations and stuff. It starts to stroke ideas, particularly for the developers, but also for the testers, of how this can be done better. All of a sudden they start to realize, okay, well, if I've got all these different permutations I need to consider and different test scenarios that I need to pass, maybe I need to approach the initial design of my software and this program that I'm writing differently to better be able to achieve that goal. And it definitely creates an improved ideation where we're thinking about better solutions because we have a clearer picture of the test it's supposed to pass down the line. So again, that's a big victory and something you like definitely want to cater for when it comes to unit testing and making sure that you have everything in place. So I've spoken a lot about the why unit testing. So right now a lot of everything's about the why unit testing, and hopefully by now you're convinced that unit testing is going to add a lot of value to your projects, and there really is a lot of benefit of testers getting involved in that unit testing, because the more that your testing experts get in there and write better quality unit tests, the better it is overall for your application. But what should be unit tested? And I'm going to now take a little bit more time focusing on the what should be unit testing before we get into the how. How do we go about writing unit tests and what does it actually entail? So what should be unit tested? What specifically types of tests are we looking for when it comes to writing a unit test? And I think firstly, anything with entry and exit points. When we think about simple code, we sometimes think, and I think the most obvious things are username and passwords. Everyone uses one. Everyone understands how that works. You have a username and you have a password, and your username needs to be entered. That's an input, and it's a clear input. There's often clear rules that go into that, and the same with password. There's clear rules of what a password should look and what's valid and what's not. And if you know that, and you have very clear entry exit points between what something's supposed to do, that should be unit tested. Whenever there's clear input and clear outputs, that's where you want to have unit test. And so that's something that you should clearly have as a unit test. Anything that's isolated in terms of functionality, when you're not too dependent, this piece of code can operate in its entirety completely, and this module operates in its entirety completely. It's not dependent on if this happens, if this happens, or this happens, and it's something that's got to bounce between 5 different services before it gets there. Unit tested. If something can be isolated, unit tested. You will always have those need for those complicated end-to-end tests that need to speak to all parts of the system, but there are often a lot fewer of those scenarios than we realize. And there's a lot of test scenarios that can be completely isolated and don't actually need to know too much about that sort of information to be able to really be able to test something properly. Unit test, anything that can be isolated should sit in a unit test. You do not want to have that sit in any form of other test. Your boundary value validations. I gave an example already about that number between 1 to 10. Boundary value stuff should be in a unit test. You as a tester should never be going into automation and needing to automate something at a UI level or an API level test, and you're writing boundary value specific stuff against this API or this UI. That should actually be at a unit test level. When you're testing what happens when a certain value is met and when not met, when it's something simple between, something higher than this does something less than that, this doesn't. That is a unit test. That is not something that you want to spend your time with as a tester. You'd rather want to go and focus on catching more complicated stuff where you're working with complex sort of types of data and trying to process that and give you really tangible, hard to get defects. If you're spending too much time as a tester catching silly stuff in the BVA stage, again, you're wasting that effort. Unit tests, clear unit tests. And much like there should be clear entry exit criteria when it comes to that, also having clear data permutations is something that can be unit tested. If you have clear data where you can put in, it doesn't have to be like, yes, we can easily think of a string or a number, but even if you've got a payload, but your payload is quite specific in terms of what it needs to look like, and then it goes in and you know that on that payload, there's very clear permutations into this value gets checked there, this value gets checked there, this value gets checked there, and it's very clear and there's no ambiguity to it. unit test that, because again, that's something where you can easily write a test, push through some data, and then you can easily assert based on the data you put in whether it, what values should pass and fail. Unit tests, those are things that should be unit tests. We shouldn't be spending time on that as testers. We want to focus on those more difficult stuff where there's really complicated things that we need to try and solve. That's really what you want. And security and performance, and I think this is a key one, because again, this is something that we don't associate with unit tests. We tend to always think about them from a functional layer. But the honest truth is that you can unit test a lot of security and performance things. You can easily, instead of getting, some ethical hacker to come and write a whole bunch of, SQL queries to see if your code can handle a SQL injection or a code injection. You can write a unit test that does that. You shouldn't need to get someone to come and check the system and do all these things. Now, I'm not saying that you should do away with security testing by any stretch of the imagination. Security testing is very important. Do that. Get scans, get those scans in place that can scan your repos and pick up vulnerabilities, get those security testing teams in to your teams and making sure that they're looking for all these things. But don't do it just at that layer. Do it at a unit test layer, because if you can start the process at a unit test layer, again, you're building that solid foundation. And really, if you have that in place, the only thing that's left for a proper security team to go and test on is the really complicated stuff. Which is really what you want them to spend their time on anyways. Those really difficult things that, that would require an extreme amount of events to be able to somehow find a vulnerability in the application. That's what you want to find. They shouldn't be finding vulnerabilities in your code very easily. And again, that's something that you can actually write unit tests for. And then the same with performance. Nothing's stopping us being able to measure how long it takes certain tests to run. And we might not think much of it because, yes, performance can be very sort of context and system dependent, and that you always need to do performance testing at that end-to-end user layer. But if you know that unit tests and modules of code always take so long to execute, if all of a sudden you've written a piece of code that's not quite optimal, and you start to notice slight deviations in the execution of your unit tests when it comes to that particular module, you can fix it right there and then. You don't have to wait for an extensive performance test later down the line to now go back and reinvestigate and now figure out what's the slowdown and the cause of all these issues, to realize that it's maybe a couple of lines of code or a couple of modules of code here and there that's affecting the performance. It's something that you could have caught the moment that code became suboptimal. You should be able to catch it at a unit layer. And that prevents a lot of issues. Now, you might not think much, oh, but I just wrote this one piece of module suboptimally. But again, think about how that scales across an application, and then this module might get called multiple times, and maybe it's duplicated, and that piece of code is duplicated somewhere else, or the same mistake that existed in that module is now being repeated in a whole bunch of other modules. It can lead to significant performance degradation if you weren't catching it at a unit layer. So again, security and performance, think about that. How do we bring that and introduce it into unit tests? Don't wait for it to be too late. So those are the things that should be unit tested. What makes up a good unit test? I think a lot of these things should be straightforward. I'm not going to spend too much time on it, but it's got to be fast. The whole benefit that we get out of unit testing is that we don't need to wait for an entire application to build and execute to be able to execute the test. We can execute the test at the code level. While the code's getting compiled, we can send through some inputs and outputs and get a response. It needs to be fast. And we need to build our unit test in a way that it should be really quick. And so it's got to be fast, not just because it's going to execute fast and get through more scenarios quicker, but obviously if you think about it from a developer perspective, having development pipelines where they want to build, write their code, deploy, see if it works. If that takes too long, it's frustrating for them. They want to be able to go deploy, very quickly realize what's not working, and then change their code, change their code. It's got to be fast. It's got to be isolated. And I've worked with developers who wanted to have as few unit tests as possible, so they created chained unit tests. Well, this is going to happen there, and then this happens there, and this happens there, and that's not what you want. If a unit test fails, it needs to be clear exactly what failed. It shouldn't be, oh, this unit test failed, let me go investigate and figure out what could have caused this problem. It should be very clear. When a unit test fails, you should go, I know exactly what failed. You might not know why it failed, you might not know why the code didn't work, but you should straight away know exactly what piece of code to look at. That's what you want. It should be that level of isolation between your tests that it makes it, a lot easier. Again, it's got to be repeatable. We're not trying to deal with complicated data that we need to create and pass through. It should be something that's the input's clear, the output's clear. And we do that because it's repeatable. You want the same results all the time. We talk a lot about test flakiness in the UI testing world, where tests are flaky and you sometimes have these failures and you're not so sure, is my test wrong? Is my code wrong? What happened? When it comes to unit test, it needs to be repeatable and it needs to always be the code that failed. Your test should never be the issue, but it's got to be able to be repeatable in that way. Self-checking, and it's that whole sort of reiterative process with the self-checking that, again, if there's a failure made, any sort of change, the test should fall. Anything going on, the test should fall. It should be fairly straightforward that, with very clear tests in place, things can become self-checking, because the moment the slightest thing changes, there is a failure. So you know that it always needs to get 100% pass rate, and you kind of start to check yourself, because you know that you're making errors along the way, that all your faults are constantly validated, and it can be self-checking. It allows you to be able to check every little aspect. If you change a test, something should still fail. So it makes sense, at least for a good unit test. It is possible to write unit tests that are always passing and flaky. But again, we're talking about good unit tests, how unit tests are supposed to be, and then timely. These things should be incredibly timely. It shouldn't be something that we spend too much time and effort on. We should be able to do a workaround and get through these unit tests relatively straightforward. So very important that those are the things. And aspects of unit testing, and this is now we're starting to get into more of the how aspect of it. So we started with the why, the what. Now we're really going to be focusing on the how do we go about writing a unit test, and some important things to be able to put in there. I think an important aspect of unit testing that needs to be understood is, firstly, something like test setup. Tests need to be set up. Your tests, are going to be run, but what you want to do is set up the module for your test, because you're going to be testing a piece of code as it compiles. You want to be able to make sure that you test that module and how it needs to be configured. Sometimes you want to plan for certain failures, and so you might, in the setup, try and switch something off in that module and say, well, I want this to deploy, but I want the system not to be switched off, and you change a variable in this system to be this. And so in your setup, you're like already preempting how this needs to be set up and execute and run. And so that's a very important part of a unit test, is that it's not just about writing the test, but it's actually setting up the tests or the code to be ready for your test, and that can be done. And that leads to another great benefit of unit testing, is that it allows you to actually run through a lot of those deep, difficult sort of permutations, even some of those negative permutations, because you can preset parts of the code to be in a negative state. So you don't need to try and wait for some environment thing and try and get some, try and mimic some complicated environment, state to get a UI test to try and do the same thing. You can often do it at a unit layer by just activating and setting a piece of code to this, build the code, set input, check output. Very important, your test setup. Mocking. Mocking is something which I've touched on very lightly, but it's very important that you understand how isolated your test needs to be. Now, at the beginning of the talk, I spoke about that puzzle and breaking down a bigger puzzle into individual smaller puzzle pieces. And those puzzle pieces you want to test well. But the truth is that, yes, those puzzle pieces will plug in to other different parts of the puzzle. But now, instead of testing that piece and that piece and that piece, and then that piece needs to be tested there again, it just creates a bigger problem that's going to lead you to an end-to-end thing. What you want to do is just say, all I'm worried about is this test, and all I need to know is that this input, this piece of application is going to send me messages, or I'm going to send it messages, or vice versa, and we're going to send, it's going to send me something, and I'm going to send it something, it's going to send me something, and what it looks like. I mock those. I'm not worried about how the system is actually going to behave. I'm worried about how it's supposed to behave. And if I put that mocking in place, that should be a part of my unit test. And again, something that I'm building correctly. Assertions. Assertion, and this is really an important naming or think to understand when we talk about unit tests, you'll hear the word assert a lot. We're always asserting a value. So an assertion is when I'm asserting an object, what am I asserting? Am I asserting that it's supposed to be this value? Is it not supposed to be this value? And so I'm going to go into a little bit more detail in the next few slides around how you arrange your tests and how you set them up. But it's important to understand that there are assertions, that essentially what we're doing in a test is we're putting an input that's giving us an output, and then we're asserting on that output that's coming through. And there's different types of assertions that we can implement there. And so it's important that you understand the phrase of assertions, because it's no longer just about pass and fail, or what are you pass fail, what are you checking? It's what are you asserting? It's like a naming convention, to understand that that's the naming convention that unit test tools use. It's understanding there's a runner. So there's a difference as well between what my test is actually doing and how my test is getting executed. And that happens at a runner level, where there's actual runners taking place as the code's getting deployed and running, and it's now getting executed. And the benefit again of a lot of unit testing is it can happen in parallel, because your code will get compiled and it can split it up into multiple different different parts and get compiled at the same time. And while it's getting compiled, it's running your unit test against the code. Those runners are those things that are doing the actual compilation. And so a lot of unit testing tools have got what's called a runner, where it's taking your test and running it against your code. So just a naming convention, but something important to understand, that there are runners that are actually taking the code and actually physically building that module and executing everything against it. It all happens very quick and seamlessly, but they are there. And then another important aspect of unit testing is really your reporting and results. And I put this specifically there because I know a lot of testers that are writing unit tests, and I even know some developers that are writing really good unit tests, but it's simply just they run passes, they move on. Run passes, they move on. They don't really report a lot on how these things are. They don't actively go back and check and keep a log of the results. And so, we then kind of, it's just something that sits in the background and you don't focus on too much. Whereas what you should be doing with unit testing is really highlighting the results of your unit test, the number of tests that are getting executed, how many pass, how many failures are you catching? Because again, that gives you a better insight of what's going on at a unit test level. And so you want to build that in. So aspects of unit testing is to think about your reporting and your results that are getting produced from your unit test. Don't just think, oh, it must pass everything and then move on, which unfortunately what a lot of pipelines do. You need to be thinking about, how am I going to report on these results and show these results to the business to show the value that the unit tests are adding value, and to be able to see that value in a project itself. Another good thing about how you go about writing unit tests, I mentioned earlier on that unit tests can be a good way of documenting the code. And a lot of that boils down to the naming conventions in your tests that you're going to apply. And when you want to name your tests, you want to think about things about the requirement that it's supposed to meet from a traceability perspective. The method or case that's under test that you're trying to test, have you considered that? What's the expected result? Is it a positive? Is it a failure? What am I testing for here? Or an input or output state, whatever it is. When you're reading the test, again, it should be clear just from the naming of the test what it's supposed to do. And this is where your unit test, you actually want to have as long names as possible. I've put some examples here. By default, constructor should create an empty GIS map. That tells you that it's looking at a default constructor and it's looking to be able to create an empty mapping thing. Another test name should always delegate XML correctly to the customer handlers. Maybe not the best example, because that can be a little bit ambiguous, but again, it's something that's long and it tells you a lot more about these things. Or perhaps a more obvious one, dog object should eat homework object when hungry. By reading that, I know straight away when an object is hungry, the dog object is going to eat the homework object. Should I say that when the dog object is hungry, it's going to eat it's very clear when I read that what the test is supposed to do, and you want to make sure that your tests are named that way. And so when you start the test and you name them as detailed as possible, so that again it comments and documents your code in a very good way. But now, how do I now go about arranging my tests and thinking about this test? And I will get into some examples of how these tests look like, don't worry. But it starts with arranging the objects. I now need to arrange my test correctly, and it starts by arranging the objects. I obviously, I spoke about test setup earlier on. You want to be able to arrange your objects, get everything ready. You want to configure everything that you're going to be testing and asserting on to make sure that they're in a certain state of readiness for you to be able to test what is it you're intending to do. So you set it all up. You're then going to act on that code. You're then going to execute what it is that you're trying to do. You act on that object, and then you need to assert that something is as expected. That can either be true, not true. I'll go through some of the different assertions that we can get. But that's the level of thinking that you need to understand. It's arrange, act, and assert. It's 3 A's. And if you can think of that and how you structure your tests, you'll always be able to write really good unit tests and be able to read unit tests and make sense of them. There's always some form of arrangement going on where the code's arranged. There's always an act where something is executed against the code. And then there's an actual assertion where I'm now testing that value there. And so something really important to be able to understand. Great. Another key thing around how do we go about writing unit tests is that the tests need to be minimally passing. And when I say that, you don't, again, you want to make sure that tests do exactly what they need to do and nothing more. You don't want to be able to this test this thing and this feature and this feature and this. No, your test just test one thing. It should just pass one thing. Rather have multiple unit tests with lots of duplication than 1 or 2 unit tests that cover every scenario. Yes, it might sound like, but you don't want the duplication. But again, you've got to think about it that these tests are getting executed hundreds of times. And if we're not doing a really good job at writing proper tests and putting them in place, we are not going to know exactly what failed where. And so it needs to be very specific what your test did, and when it failed, it needs to be very clear what failed. So something very important to do. And another note is obviously to focus on behavior and not just coverage. Unit test coverage is important. There's a lot of tools out there that can measure unit test coverage, so you can aim for a 90%, 100% unit test coverage. That's important, but it shouldn't be your main goal. Your main goal should be focusing on the behavior of how the application is supposed to work with. And I say that because a lot of, I've seen a lot of developers write unit tests and it does what it's supposed to do, but their test examples and they're like data examples that they put in are things that would never happen in production. It would never look like that in the first place. And yes, I understand you just want to make sure that this module reads this particular type of data, but rather add some sort of test in there that's maybe mildly sort of customer specific, so that you can ensure that when it's actually deployed, it will actually match the customer's behavior and how the customer is actually intending to use the software. So again, very important. And I think here, what you don't want to do is for your unit tests to make decisions for you. You shouldn't have complicated unit tests that now have got if statements in them. A unit test should be something that you input something simple and you get something simple. You get an answer. If you now need to start having sort of an if statement and some sort of complicated sort of process of now I need to read this module, and based on this module, if it's that, execute this. If it's that, you don't want that. Why? Because obviously it makes your unit test more complicated, and you want your unit test to be as simple as possible. Clear failures need to be able to be clear failures. But I think the other sort of thing is, the more complicated your unit tests get, the more likely your unit tests are to not be valuable. Your unit test should never be something that needs another unit test. How do you know that this unit test actually works properly? And now you need a unit test for your unit test to make sure that it's actually getting the right answer. You shouldn't need to have that layer of complexity to your unit tests. It should avoid all types of decisions. You want it to just be clear input, clear output. Something important to keep track of. And use helper methods. There's a lot of stuff out there in the unit testing world which help with a lot of the setup and how to achieve a lot of results around data and getting things done. Don't try and reinvent the wheel by doing all this complicated stuff yourself. It's something that you can do using a lot of different helper methods. Make use of them. Make your life as simple as possible. Unit tests can be quite complicated to sometimes put together, but there's a lot of tools out there that make it easier, and a lot of methods that allow you to be able to analyze things within the data. Use them. it can definitely add a lot of value to your unit tests without you needing to do too much coding. So very important. And then avoiding multiple asserts. Tying in again earlier on with the whole sort of traceability thing, a test should just check one thing. And if you've got a code and you're like, but I want to check that if this value meets this criteria, this criteria, this criteria, and this criteria, then it's valid. You want to avoid having too many multiple asserts, because all of a sudden the test fails, but now you need to know, okay, well, that test failed, which criteria didn't it meet? Again, it should be clear that it failed on this particular assertion straight away from the unit tests. And you can check the results and see that stuff. But again, it should be very clear that just that test failing means that this part of the code is wrong. And so you want to avoid multiple asserts, rather have multiple unit tests with one assertion where you're repeating the code at the same time than the opposite. Because remember, unit tests run very quickly. And so when you've got something that runs in a matter of milliseconds, you'd rather have 100 things that execute in a matter of milliseconds than have one or two tests that might still be quick, but now when it fails, you're not 100% certain of what the failure is. The amount of human effort that you're going to spend just trying to figure out what really failed and going through the results, just from doing it once or twice is already going to outweigh the value you get from having written multiple ones over again and then allowing them to execute on a regular basis fast. So just don't do it. Avoid multiple asserts. Great. But yeah, and before I go into a little bit more detail on some of the other sort of specifics, just some unit testing tools to be aware of now that I'm going into a little bit more detail of now we're going to actually get into some of the specifics of how the unit tests look at a code level. It's also just to understand the different types of unit test tools that you get. There's JTest, JUnit, those are Java-based things. There's JMarket, which is a Java-based sort of market thing. There's NUnit, which is more for your C# things. PHP's got its own sort of unit testing tool. Emma is another popular one out there. This is high level, just a few. There are loads of unit testing tools out there. There's CTest, Jest, which is Facebook's language, is a very good unit testing tool for React. And then also, some of their sort of APIs as well it's very efficient at testing APIs at a unit level. So, but there's a lot of unit testing tools out there. I just put the slide up as an example to say get familiar with the tools as well. They all work the same way. These tips that I've just given on how you go about writing tests apply to all of them. But do be familiar that they're there, and they normally tend to be in the language of the program that you need to execute. And I think that kind of makes sense. If you're writing a PHP application or a Java application, as it's compiling, you can't now run something that's in a different programming language that now needs to be compiled differently before it runs. It's got to be in the same sort of programming language. So that's the one thing that's worthwhile getting into, is that unfortunately with unit tests, yes, they will need to be written in the language of the development thing. The only time when it's a little different is when you've got your JavaScript, TypeScript thing. Anything that's kind of Java based can generally run on something. So JavaScript and TypeScript also run on a JVM, and you can often just use like a JUnit test to be able to still test those, because from a compilation perspective, there isn't a change. Just something to keep in mind. But there will need to be some sort of programming language specific thing that goes in there. Great. And now I mentioned different types of assertions that you can get. And so here's an example of things around, an assert array equal. So you want to assert something that, that something is equal to something. You can do that either at an individual level, you can do it at an array level. You can assert that some value is true. You can assert that something is false, that, does it actually match this? Does it not match that? Is something null? Is it not null? Is there a value there? Is there not a value there? Is something exactly the same as what I'm doing? Is it not the same as this value? Or is it just, does it match this exactly? There's a lot of different types of things. There is more assertions than this, but I would say if you can keep your logic to these basic assertions, you can generally unit test everything. And if you can just keep it to these basic assertions, you generally tend to have more simplified tests. So yes, there's a lot of different types of assertions that unit test tools offer, but you don't want to go too complicated in your different types of assertions. You'd rather want to make it very clear what it is that you're trying to solve and stick to one of the basic assertions is generally what I would advise. There's also what's called a matcher. Now, a matcher is really just some sort of like a logical sort of thing where we're now saying, if I need to match something, does it need to match anything related to, does it just need to be anything? So you sometimes want to add a value and you want to just make sure that this value is popular. It can be anything you're not interested. You sometimes want to do that. You sometimes want to be a bit more specific or logical in terms of the values that you're looking for. You'll see some things around the not vol null or null value thing, or something that's going to be equal to exactly. So the matches kind of goes hand in hand with your assertions, where you want to search something, but you sometimes want to just match that what you're getting is exactly the same thing. And so that's something to be aware that you have your assertions and you have different types of matches that you get within unit tests. And I do want to just say this as well, testing for exceptions. And I think this is a key thing, that your unit testings can also be very good at testing for exceptions. And you want to make sure that you are considering things when you're writing a unit test, that you are always testing for exceptions. Don't expect there to be a true false value all the time. There's true false and something weird happened, and you need to always make sure that those type of things happen, and always write a unit test for that. So here's an example of one where I've got a public void test for thing. I've got a unit where my unit is, and now I'm going to have my unit, and I've written something where it's going to throw some sort of funny argument exception. So something that I've written. So this is what my code is actually going to do. And now in my test, I need to just make sure that it actually fails. I'm going to try that my unit throw illegal argument exception actually fails and gives me the right error message. And so by doing that, I've now been able to cater for the fact that, I've tested something and I've got two different tests that are now testing against different sort of exceptions, and making sure that it's not just clear sort of pass and failure things, but anything going wrong I can catch. And you want to be able to catch that as well. So even if code just does something funny, it shouldn't just fall over and then everything goes on. You want it to fail gracefully, test for those exceptions, and fail the test. The moment something weird happens, you can have a catch E. We've probably have all done some sort of programming course, and there's always that catch E, catch error, whatever error you get, catch it and do this with the error. So either completely ignore, or this exception is completely expected, or it's just catch, fail. But you want to make sure that it fails and it's clear that that's there and that you are testing for those different exceptions. Then understanding something around stub mocks proxies. A stub is really just working with stub data. I think we have to understand what a stub is. It's when we're stubbing data. We don't want to work with anything that's dynamic. We're not going to try and have some sort of that dynamic logic data. We're making it very clear that this is the input, this is the output. Work with stubs, very important. Unit tests need a lot of predictability in how they do so. Work with those stubs is very important. Then understand the mocks, where we're understanding mocks. And so you have your unit test, your unit, and that interacts with the mock. And a mock is where you're writing some form of application where you've kind of, well, not so much application, but you've put some rules in place of the system that I'm going to be working with is going to behave a certain way. So if I send it this system responds this. If I send it this system sends this back. And you create a mock that kind of mimics how your dependencies will work with your code. And important to just understand that. That needs to be in place for a lot of your testing. Mocks are very important. And then you get something like a collaborator, or I prefer to kind of have some sort of proxy where it's kind of, instead of sometimes testing the actual module itself or a mock of something, it's a proxy that's communicating between the two. And sometimes you also got to test and be aware of the proxy, and you need to write a unit test for the proxy as well, or the collaborator that you're doing. You don't just want to worry about your end module. Think about like queuing systems as well. We have queuing systems, and you now need to be able to send a message to another system. You don't just want to test the individual systems behaviors, but you want to test anything that's going to be the proxies between the two, and communicating between the two, and collaborating, helping that message transfer. Write unit tests for those things as well. And those are things that you want to kind of build into your unit tests, and understanding that they're there. And I want to also just say that, and I think this is the last important point I want to take before we just want to look at some code, is testable and untestable code. Unit tests are a very good way of being able to identify when a code is not testable. If you can't write a unit test for the piece of code that you're writing, there's a good chance that you're designing it incorrectly. Everything should be testable, and you should be able to write unit tests for every part of your application. And if you're struggling to find how to write a unit test for something, scrap your code and start again. It should be easy to write a unit test for something. It should be easy to test an application. And if you're struggling to wrap your head around, there's a good chance you're thinking about the problem wrong. And so the best way to ensure that we have testable code is through a unit test. And when you're writing unit tests, it's a good way to be able to identify when code is untestable. And so it's just something I want to put in there as well. Very important to have within that. But yeah, give you an example of something. Here's some code. Again, something really basic. It's a get static string, get time of day. So what it needs to do is just get the time of day. And so what it does is it just searches the time of day. This is what the code actually does. And based whatever the code is, it's going to tell me if it's between the hours of 0 and 6, it's going to tell me that it's nighttime. If it's between the hours of 6 and 12, it's going to tell me that it's morning. And if it's anything between 12 and 6 o'clock, it's going to say afternoon. Otherwise, it's going to return evening. So what this code does is it gets the time of day and then tells me whether it's morning, afternoon, evening, or night. That's all the code does. Great, seems pretty straightforward. The problem is, and this comes into that testability part of it, is that how do I test this? Because now the date time has got to always be now. And the code actually has it in there. That's always now. So no matter what I do, it's always going to say check now, check now, check now. And so if I'm running this, and I'm going to be running this at 2 o'clock in the morning in my pipeline, it's only always going to become a night. It's never going to test the other scenarios. And you might say, yes, but why don't you set and reconfigure your environment to be a certain time of day? That's not very helpful, because now I have to stop, reconfigure my environment to be a different type of day, run the test, check. That's not scalable. You can't stop a machine, change its settings, restart the tests. It's just not a feasible way of doing it. This is a great piece of code that will do exactly what it's expected of, but it's not testable. And when I'm trying to write a unit test against this, I'm going to struggle. So rather, what I'd want to do is, instead of saying date time equal to date time dot now, I can have a look here where I'm now writing this, in my test method, what I want to do. And here's where I'm starting to assert. I want to say, I'm going to be change the system time to test, and then I'm going to range it, act string time of day, and then assert it is equal to 1. That's how I'm going to write my test based on that code that I'm going to do. So how would I write that test? I would be able to, again, change the system time, get it to the time of day equal, and then tear it down. This is time consuming. So yes, it'll work, and I'm creating one for each individual morning, but it's not the most testable solution, but I can write it. So what I'd rather do is redesign my code to be able to get the time of day, where I can get the time of day from a value, and then say, well, get time of day, and where I can set it, and then I can assert whether something's equal or not. And if I can do that, and if I can write my code in such a way where I can input what I want the time of date to be, it makes it a lot more testable. Now, you might be reading that thinking, as a dev, but it's doing its job, this is time consuming, it's doing more things by doing this. Yes, it is, but it's a lot easier to test. This code is now infinitely more testable. It actually makes it better. The fact that I can, by passing parameters through, control the date times and be able to pass and fail my tests a lot more easily, actually makes it a better application overall. And that's kind of what you want. You want to aim for that. So something that you want to do. I'm going to give you another example. Here's something of this is a Scala function where I'm looking at different sort of like pizza toppings, and I now want to write a test, and I need to have something where I've got multiple different types of toppings. I'm going to add a topping, and the toppings can be of different types of things, and I'm going to remove toppings, and if someone adds a topping and it's going to throw an error, it's going to send boom, and I'm now going to go and deploy that. How can I look at that differently as a testing perspective? That's problematic. But how would I go around writing a test for that? Is I would try and, now in this particular one, I've imported a lot of things. I'm going to start off by trying to say that my variable, I'm going to create a variable pizza, and before that, there's going to be a new pizza that needs to start, and then I'd have a test saying, okay, has 0 toppings, and so I'm going to assert. But if we go back to the previous slide, you know, you got your add topping, your remove topping. I'm now going to assert values on each individual one of these things, and I've got add topping. So I'd go add topping equals this, and then I'm going to add it to 1 and say that if I now add a topping green olives, it now needs to be equal to 1, and I can do a lot of these things, and I can you know, create a lot of values in there, and now start adding error messages to say, well, not green olives, let's do something. So this is now taking some code and trying to write unit tests around it, and you can, you know, by breaking it down. But the important thing to remember is that you've got to now break it down into these scenarios, and being able to get it to work for you. I am going to show you a piece of code here, for instance, and that's a more difficult example. Here, have a look at something like a calculator. Now we all know how calculators work. And so if I'm going to write, this is a calculator that's been written, and if you, let me go through this and then I'll show you, talk you through my GitHub repo. Now I want to test that something is, that my test sum button actually works. So I put in 2 numbers and I say test sum. And if you want to know how this particular example works, it's not really a functional application. It's really just testing different sort of functions, and you can read the Java code that actually will show you what it's supposed to do. But if I go now into my calculator test of Java and see this, I have a test sum, and given this value calculator is going to equal to new calculator, I'm going to take 2 things. I'm going to sum them because my calculator is going to run its sum function, and now I'm going to check that if the result is not 4, I'm going to say that it failed, and that's I'm testing my sum. And now I'm doing the same for a minus, and I'm going to say for that. So I've got my setup where I set my new thing up, and I'm going to assert that this is going to equal to 0, and you can see I've just done it a slightly different way, but set it equals to 0 when I'm running my calculator minus 2,2. I can do the same for a divide. I can do the same for something else that I wanted to check, where I get an exception where I try and divide by 0. I can also do the same for a multiplication. If I wanted to do a multiplication, I would then try and say, go have a look at my code and see it would be able to go calculator.multiply and put 2 values together, and then actually see here. So here, this is an incomplete unit test. If I wanted to do this, I've got this here, and I've got new calculator, and I'm saying calculator divide 6,0, but it's not a complete unit test. What I still need to do here is I need to go edit. I'm just going to do it in the browser for the sake of time. And I would then need to assert error, and then put in my error message that I'm going to get from that, or invalid input, whatever it might be, and put it in there, and actually go and assert that this is what I'm doing. I'm now setting up for failure, but now I need to assert that the failure actually happened. So I've put here that this is divided 6 by 0, but the actual failure itself still needs to happen. So you can see a good example here of how a very basic sort of framework can work. And by the way, if you were to go to my GitHub repo and run this, there will be a failure. There is actually faults in the code that need to be fixed, deliberately so. And then I've also got one here where this is something where you're setting up a mock and you want to just basically verify someone's address and where they stay. And so we've basically using Makito, which is just a Java-based mocking framework that gets set up, and by using it, and I'm mocking how it's supposed to handle different sort of address environments, I can then go, given this sort of advice, I've kind of put this one in more of a BDD sort of framework, but as you can see, this BDD, it's kind of similar to the AAA, where I am kind of setting things up, I am performing an action, and then I am doing my assertion. So if you think about it from BDD perspective, it works exactly the same way. Just here, I've just changed the wording to be more more BDD related here, whereas here I've done it. I've just shown you there as well. So given then what it's the same as those 3 A's I gave you, where you want to arrange, act, and assert. Exactly the same thing. And you put it here. I arrange it. I want to call a customer with a specific address where I want it. I'm then going to say where I want it to return. I'm then going to call it with a specific customer and then assert that the address is actually what I'm expecting for that particular customer, and then some examples here. And so the reason why I'm going through this is because I think this is something which I think will be handy. So in my repo, which I think I've shared on your notes, but if you need it, I can post it as well. I've got a couple of different sort of environments things here where I've got this unit test example. I've also got an advanced JUnit test example that you'll be able to see. So I've got unit test example and an advanced JUnit example, which I think would be useful stuff to go through just to allow practicing basic sort of unit test. And the advanced one is just looking at mocks and trying to see if you can get that to go. But I've also put a link here to not training that I made, but there's some really good unit test training here that if you click on this particular repo, it points you to the direction from Florin Koros, who's actually wrote a book on good unit tests and put together some training, and you can work through the training here and all the repos in terms of demo exercises are there in terms of being able to actually get hands-on with unit tests and be able to write and do them a lot more effectively. And so there's definitely some good sort of stuff that you can get in there that I would definitely encourage. But I want to be aware of the time that we have left, and so wanted to see sort of if there's any sort of other questions that anyone has during this time. Anyone got any questions, things they wanted to ask? So I do see there's some stuff in the chat group. Again, anyone got any questions they wanted to ask? Okay, I see someone's asking a question. You'd like to know regular unit testing scenarios. Is that regular or regression? How to start that initial days? It's regression. Okay. I think that an important thing to remember with unit tests is to, when you start out with building your unit tests and getting things together, it takes a lot longer to be able to write proper unit tests than what it would to be able to just write code and basic sort of tests. So it does take a lot longer to get these things right. And I think that's important to just remember that it does, start to get these things. It does take a long time to get it right. Once you get it right, once you get familiar with how to write unit tests and get your regressions in there, it helps a lot. And it takes a long time to eventually get them written and to write a lot of detailed stuff. It will slow your testing down considerably. So I mean, your development down considerably, and developers will spend a lot more time, and they will feel like what was taking them 3 days to write is now taking them 5 days to write. But if you add that up over the regression cycles, where now those tests are executing multiple times a day in an automated fashion, very predictably and very reliably, it helps to make things up, which is great. Another question is JUnit coming under white box testing? And the answer is yes, it should. You can write your unit tests without seeing the code, particularly in BD. So I mean, like in TDD, this is what you do. You actually go and you write your unit tests, test as well. So I've just got what's called load shedding in South Africa, where I've just lost my monitor, but I am stable.
Hello, I guess there is some network issues with Craig. We'll wait for few minutes so that he can rejoin and answer the questions.
Uh, hey, hi, Craig. So I have one question. Can you throw more light on mocking? Like what kind of tools which you use?
I think he's not available yet, Jyoti.
Okay.
Very sorry, ma'am. I guess due to some network issues, he just got disconnected. So we'll wait for few minutes. If he'll be able to join, then he'll answer the questions.
Okay. Fine. Alankrit, I guess he's already entered the main.
Yes, ma'am. Yes, ma'am. I just called him and he said he'll be back in a minute. Just a minute.
Perfect.
Sorry, the schedule on the ATA website is showing 4:04. May I know this? What are the next sessions on both the tracks?
Sir, for this track, we have a lab on performance test engineering beyond record and playback by Sailesh and Rishil. And for track 2, let me just confirm. I'll get back.
Yeah, I think Sumit pasted it. Thanks, Sumit. Thank you. Yeah, I got it in the chat. Yeah, thanks, Alankar.
Hey, hi, Craig. Are you there?
That. Sorry for that.
Okay, no worries.
I'm here.
Yeah. So, Craig, I have a question. The question
Sure.
is, like from unit testing point of view, mocking is really very important. What are the tools which you would recommend for mocking?
There's a lot of frameworks out there. Makito, if you're using Java, is a very good one, because I think it's, it certainly adds a lot of value just in terms of, being able to build up a lot of the things that you need, and so you can basically build up any sort of application, tell it what you need. There is another. There's a
We are again having a lot of disturbance from your
Java
end.
based, but there's also an API mock. Makito is the one that I've generally relied on.
Sorry, Craig. We are having a little bit of disturbance from your end. Maybe if you could switch off the video and maybe answer, maybe that should help.
Yep. Okay, well, switching off my video, maybe that will help.
Yes.
Okay. Yeah, I was going to say Makito is the one that I've worked with the most from a Java perspective. I find it works quite, but there is a variety of other ones that you can use that generally work quite well. That allows you to build whatever it is that you need on the one side and to call a function, but then also just be able to very easily create something and tell it what is you need. There's also some really good tools out there where you can even just make an API call and tell it what you want the response to look like, and it behaves exactly like an API, but you're literally mimicking the responses. I just can't remember the name of it right now.
Right. Also, from coverage point of view, like what should be more important, the code coverage or the branch coverage?
I think when it comes to coverage, you want both. You shouldn't be measuring just one. I think code coverage or branch coverage or decision coverage, whichever you want to measure your coverage, they're all just metrics. And if you're just looking at one metric, you're probably going to miss out something on the other. And so you have a lot of tools these days that allow you to check them from multiple percentages. And typically what I would then say is that it's got to be you want more than 90% coverage on the lines of code that need to be tested, and 100% coverage on your decisions that need to be hit. And if you can do something like that, where your decision or your branch coverage is hitting every single possible scenario, but then there's obviously the lines of code that are maybe getting missed, and that's at least above 90%, I think that you're going to get really good solid test coverage results. 100% is not always possible, but obviously it's something to aim for.
Right. Yeah. So one more question, like we spoke like what all things should be done for this unit testing, but are there any points like which we should be avoiding when we are writing unit test cases?
I think there's always going to be things that need to be avoided. And I think for me, I found a lot of it, you sometimes get these things where you need to test very complex scenarios. I've worked for a couple of companies where we needed to test certain data scenarios which required large amounts of data to track something at a historical level, and if you took a customer and they had so many years of history to be able to do something, you would require certain results. And because it was so specific and it required lots of data to be able to get that right, you don't want to unit test stuff like that. That's not something that can be unit tested. It should be something that's very clear and simple. And you do get those tests that do need to be end-to-end tests. You sometimes get those scenarios which can only really surface when this system speaks to that system and this system does something as a result of that, and you can get to an end-to-end scenario. So you always need those end-to-end testings, but it should be your complicated tests and those difficult things that you should be spending time on in your end-to-end tests and trying to automate, not simple things. Your simple things can be unit tested.
Okay. If anyone is having any more questions,
Yeah, I have one question.
yeah.
Sure.
Like, what is the percentage of coding or unit testing as a QA we need to be involved? There should be certain parameters. Like, so what is, as per your experience, do you distinguish any such?
I think it's difficult to put something to a percentage because it probably looks different for each different types of application. But I would say that you as a tester, you would want to at least spend a good 20-30% of your time looking at unit tests. Because, and how I've typically done this in organizations I've worked with, and I understand every organization's got different sort of complexities and different behaviors. But typically we've always made it clear that it should be the developers that write the unit test, but then we get a lot of assistance from the actual testers themselves. But then the testers would go in, and before the developers even started writing the unit test, they were like already writing comments in the code to say, I need a test for this scenario, and they would literally write all the scenarios down as like a to do to make it clear, and then they would go and review the unit test afterwards and be able to get that. And then if they can think of any more that are missing, they sometimes start to add to it as well. It really depends on how willing your company is for testers or devs to be able to get involved at, on either side of things. But I think bare minimum, you should be spending 20% of your time at a unit test level, going through, making sure your unit tests are solid, and trying to improve coverage at a unit test layer, and not trying to leave things for too later.
Right.
But no, great question.
Extension to this question. How about integration test along with unit test? Whose responsibility is it?
Good question.
That's a very good question. Where I'm currently working, we've put the integration tests as a tester's responsibility and the unit tests as a dev's responsibility, with the testers reviewing the unit test as well, but then they're responsible for the integration test. But it can work differently. I've also worked in another company where we work together as teams across all of them, and then devs and testers work together on all levels of tests to be able to make sure that they were in order. It depends on the complexity, in my mind, of the integration tests. If it's something that's quite complicated, sometimes it's best left for the developers to try and, if there's a lot of config and setup it's sometimes best for developers to get in and just have the testers review. But it does depend. Where I am at the moment, we've got the like clear line of accountability sits with the devs on the unit tests and the testers on the integration test, but we still have the testers reviewing the unit tests.
All right.
I don't think there's a right or wrong answer to that, though, unfortunately.
No. This is like quite debatable, right?
Yeah,
There's
exactly.
Organizations which are saying that it is like tester's responsibility even to have unit tests, but there are many organizations that they say that unit test should be only developers' responsibility, and from integration it should be the testers. But again, it depends on organization to organization, and then we
Yes.
just need to see that we are just balancing out the test pyramid, right? So that's more important.
Exactly.
Right.
We want to get to
Right.
the end goal rather than like try and be too pedantic on the process.
Right. And again, just between the two frameworks, NUnit and JUnit, I know like both support different technology stacks, but which is more efficient as per you?
Sorry, say that again. Between
NUnit,
JUnit and NUnit.
right, which is more efficient?
NUnit is probably more efficient. It depends on how you want to measure efficiency. NUnit is more efficient in terms of actual execution. JUnit uses a JVM. And so if you were to say spin it up in a pipeline, it would require a container running Java to be able to execute those unit tests on. Whereas NUnit doesn't necessarily need that, but sometimes you need JUnit. But again, if you've written a whole bunch of stuff in JUnit and you're using certain sort of Java libraries in your code, you have to use JUnit depending on what it is that you're trying to write unit test for. But I think NUnit is probably more efficient from an execution time perspective and from the amount of space that will be taken up from a container perspective. You can run NUnit in a smaller container.
Right. So we have one more question, like from Rohit. What he's saying is, which is better, JUnit or TestNG?
I'm going to say it depends on how you use them, because TestNG can be used for unit testing, but it can also not be used for unit testing. And you can, I think TestNG is incredibly powerful, and I've had no issues using it. I do find that people who use TestNG sometimes have a habit of setting it up in a way where it's not running effectively as a unit test, and it's actually now going, waiting for code to be deployed, and then wait for some of the TestNG to be executed. But I think they're both very good. I won't say one's necessarily better than the other. I think it's just how you use it.
Right. Even my experience is same. Like if we look at JUnit, latest version of JUnit is quite much powerful and provides almost the same capability as TestNG. But again, it depends on how you use it. What is your need exactly?
Exactly.
Right. It was really nice and informative session, Craig. I really enjoyed it. And
thank you so much.
Really nice. I already have your GitHub link and I'm going to follow it. So over to you, Alankrit.
And Jyoti, click
Yeah,
the link he shared about Sandal Desk website. It is we are getting as a 404.
Let me just see if I can copy that again.
Yeah, sure.
Please do. Any other question before we move to next?
There we go. Try that one.
Perfect.
So that's just my blog site. I've got some articles in there that you can read.
Okay. Yep. Thanks.
Okay. Thanks everyone, and apologies for some of the tech issues. We do have some network challenges from time to time here, but thank you so much for your patience.
Okay. Thank you very much, Craig. Once again, have a great day.
Pleasure. Thank you.
We will be connected on LinkedIn. Thank you. Bye-bye. Alankrit, over to you.
Thank you. Bye.
Yes, ma'am. So thanks a lot, Craig, for your valuable time and a great interactive session.